So for this lesson, we're going to cover 4 theorems regarding parallelograms. So you may ask, what is a parallelogram? Well, by definition, a parallelogram is any quadrilateral where the opposing sides are parallel. So, as you can see, these two sides are parallel to one another, and these two sides are parallel to one another. And usually in diagrams, to denote if two lines are parallel, they're shown with an arrow. So you can see that the green ones have one arrowhead to show that they're parallel to one another, and for the red one, we're going to put two arrowheads to show they're parallel to each other. So any quadrilateral that has opposing sides which are parallel is referred to as a parallelogram. Now, we're going to cover these 4 theorems regarding parallelograms. And as we go through the theorems, you'll see that each of these theorems basically refine the definition of a parallelogram further. And let's start with the first one. First theorem states that the opposite sides of a parallelogram are equal. Well, firstly, what do we know about a parallelogram? That the opposite sides are parallel, right? So we have that AB is going to be parallel to DC and AD is parallel to BC, and which we know from the definition of a parallelogram. Next, what I'm going to do to prove that the opposite sides of this are parallel is I'm going to draw the diagonal BD, and when I do this, you can see that since AB is parallel to DC, that means that angle ABD is equal to angle BDC because of their alternate angles. And in the same way, since AD is parallel to BC, angle ADB is going to be equal to angle DBC, again because they're alternate angles. So by doing this, you can see that we have two triangles here, ADB and triangle CBD. And these two triangles share the line BD, but they also share the angles which we proved earlier to be equal. So that means that these two triangles by angle side angle are congruent. And since they're congruent, then that means that the following sides AB is equal to DC and the side AD is equal to BC. So that proves that the opposite sides of a parallelogram are equal. Now, what we're going to do is prove this theorem, but in the other direction. Basically, in a quadrilateral ABC, suppose that AB and CD are equal and AD and BC are equal, then ABCD is parallel. So in the previous proof, what we showed was that if you have a parallelogram, the opposite sides are equal. Now we're saying that if you have a quadrilateral with opposite sides that are equal, then you have a parallelogram. So let's prove it. So from the theorem, we know that AB and DC are equal, and the dashes are a way to denote that two sides are equal, and AD and BC are equal. So with that in mind, again, we're going to draw the diagonal BD. And when we do this, again, we see that we created two triangles, and these two triangles not only share this line BD, they also have equal sides with this one, and then this side is equal to this one. So because of that, by SSS, triangle ADB has to be congruent to triangle CBD. Now, knowing that they're congruent shows that the angle ABD has to be equal to the angle BDC, since in congruent triangles, the corresponding angles are equal. Same way, angle ADB is equal to angle DBC. So because these angles are equal, then by the fifth postulate, or also known as the parallel postulate, we know that AB is parallel to DC and AD is parallel to BC. Now the next theorem that we're going to cover is in a quadrilateral ABCD, suppose that AB is equal to CD and AB is parallel to CD, then ABCD is a parallelogram. So again, just like the previous ones, we're going to draw the diagonal BD. You could also prove these using the other diagonal AC, but to be consistent, we've been using BD throughout the proof. Okay, so now that we've shown BD, and we know that AB and CD are parallel plus equal, then that means that angle ABD has to be equal to angle BDC, since AB and DC are parallel, and that makes them alternate angles, plus the two triangles ABD and CDB share now an equal side. This equal sides this angle and this side. So that means we have a side angle side. So because of that, since we have a side angle side, that means ADB is congruent to CBD. And then that means that this side AD has to be equal to side BC because of the congruence of the two triangles. So that proves that it's a parallelogram. Now if you remember, the definition of parallelogram is a quadrilateral with opposing sides that are parallel. But here we're saying that AD is equal to BC, which is enough to say that the quadrilateral is a parallelogram. And the reason why we didn't go further and try to show that AD is also parallel to BC is because in the theorem before, we already proved that in a parallelogram, not only are the opposite sides parallel, but they're also equal. So we can stop this proof by just saying that AD is equal to BC without going through the further steps of trying to show that AD is parallel to BC. Now the last theorem we're going to do is a quadrilateral is parallelogram if and only if its diagonals bisect each other. Now, when you have the phrase if and only if, then what you have to do is you have to show that this theorem, you have to prove this theorem in both directions, which means we have to first show that a quadrilateral if it's is a parallelogram if its diagonals bisect. And then in the next step, we have to show that if the diagonals bisect of a parallelogram, if the diagonals bisect of a quadrilateral, then it's a parallelogram. So first we're going to go show that parallelogram implies that the diagonals bisect. And then in the next proof, we're going to show that the diagonals bisect means it's a parallelogram. So first, we're going to draw the diagonals and assume that they meet at point P. Now, by doing this, we see that angle BAC is equal to angle ACD because the quadrilateral is a parallelogram, and so that means these are alternating angles. Same way, this angle is equal to this angle, again because it's a parallelogram and they're alternating angles. So also we know that these two sides are equal because it's a parallelogram, and opposing sides of a parallelogram are equal. So now we have these two triangles, and if you look at these two triangles, they share two common angles and a side. So that means by angle side angle, these two triangles are congruent. Since triangle ABP is congruent to triangle CDP, then that shows that side AP is equal to CP and side BP is equal to side PD. So since those sides are equal and they all lie along the same line, then that means that point P is the midpoint of both these diagonals. Thus the diagonals bisect. And so we've shown that if you have a parallelogram, its diagonals bisect. Now we need to show that if the diagonals of a quadrilateral bisect, then it's a parallelogram. So we're going in the opposite direction now. So if you see in our diagram, we already have a quadrilateral and where the diagonals meet at point P, and we're trying to say that AP is equal to CP and DP is equal to PB. So this is what we're already assuming. Now we know that angle APB and angle CPD are equal because they're vertical angles. So now that we know that each of these are equal, then if you look at these two triangles, we see that by side angle side, those two triangles, which are ABP and CDP, are congruent. And this implies that the base side of these triangles, which is AB and DC, must be equal. In the same way, we have these two angles, which are vertical angles to one another, so that means they're equal. And since they're equal, again, we have these two triangles which share two sides that are equal and a common angle, and an equal angle, that is. So again, by side angle side, we have triangle APD being congruent to triangle CPB. And since that is the case, then now we can also say that AD is equal to BC. So since AD is equal to BC and AB is equal to CD, then that means that the opposite sides of this quadrilateral are equal, which shows that it's a parallelogram.